afternoon, everyone. My name is Tianbao Zhang. Today, with my former colleague Yan, we are going to present MicroVcycle, which is an agile framework for system projects.
Yes.
Yeah. In my previous experience, I worked as a software engineer and system architect and project manager in automotive industry. And in my previous job, last job, I encountered certain pain points in the system projects. And then I approached Yan, he was leading the Agile Transition Office in our company. And then we worked out something. And I guess Yan had heard a lot of complaints there, right?
Yeah, I sure did. But it was my pleasure to work there and help out.
Yeah.
So, Nilsson, I've been working with implementing the Agile way of working in 6 different organizations now and in 3 different business areas for almost 15 years now. So very excited to be here today with my ex-colleague Tianbao to discuss about MicroVcycle for system projects. So let's get started. So this is the outline. This is what we're going to discuss and talk about today. System project running agile and versus that with software projects. We're going to discuss and talk about what is the MicroVcycle framework and why it should work. And we write should because it is a sum of isolated and different observations made. And then we put it all together in a paper, which is also available if you contact us. We're going to give you some examples and then also talk about the effect of the project when implementing this MicroVcycle framework and also team on businesses. So before we get into all the good details, let me start first to share a story. So I was working with Tianbao then in an automotive company, and as Tianbao said, I was then leading the agile transition of the company, conducting trainings and so on and so forth. And one day I got a call from a project manager, and he asked me to come and train his project, which was my job. So of course I accepted that. So we set up a date and time, and the day came, and it was time for me to run this agile training with all of the different project members. And just before, a few minutes before it was time for me to get started with the training, the project manager took me to the side. And he said, Jan, just so you know, this is a traditional and old automotive company, and I just wanted to let you know, no one believes in this agile stuff, all right? Okay, but okay, yeah, go ahead, now, do your training. Okay, wow, great. I'm getting sweaty here now in my hands. Oh, a bit of butterflies in the stomach, but okay, yeah, let's do this. So I went there and I did my training, and I got deaf silence throughout the entire training session. Not a single questions for the entire duration of the training. And then the end came, and I had no idea what they thought about it, or if they bought it, or anything. And I finally said, okay, any questions, last chance. And then one person actually raised his hand. And this was a system tester. So it was the one that was making sure at the very end then that this delivery was working as intended. And okay, yeah, please go ahead. What is your question? So he asked me, well, Jan, okay, I hear you. I understand what this training was all about and how it should work. But come on, how can it work in our company, in our environment? I even get stuff that I test that we even ship to customers that is already obsolete because the circumstances has already changed. The requirements has already changed. I'm testing things that no one is ever going to use. And I was silent actually, because this way of working, this training was all about fixing that problem, among others, of course. So I was thinking, okay, how should I answer this in a good way? Because I just did this training and now he's asking me this. And I thought that, I don't think this can go any worse. But then he rose his hand again. And then he looked at me and he had another question. And I said, okay, go ahead. What is it? And that is actually a story for another time, because now let's discuss and see what happened there. How can you end up in a situation that you're testing things that it's already obsolete? So let's take a quick look, and of course a simplified look at the so-called we model, a very popular framework for automotive companies perhaps, but system projects in general, that is then providing you a process, a series of activities, how you should organize yourself in a system project. And once again, simplified, but how does that look like? Well, we have the software teams. They have their software requirements, and they are doing their software implementation, and they are doing their thing, and they are living the high life. They are thinking everything is good, we have the requirements, we are very productive, and we are implementing this accordingly to specification. Then we have the hardware teams, and they are also really good. They really feel that, yeah, we got this. We have the hardware requirements, we are doing our development, things are going really well. And then we have the integration and test, and then you're sitting around and thinking, okay, what about us? Aren't we supposed to integrate and test things? But these teams are working in isolation, and if you listen to Henrik's talk before lunch here with the waterfall, it is a very heavy waterfall process. So everyone is doing their thing in isolation, in steps, and not really integrating with each other. But eventually then, and then we have the product manager then that feels that, oh, well, this is going fine. We have our Gantt charts, and we have the teams, and they're reporting progress, and they are implementing their requirements. We are on track. Then you suddenly realize that we can finally integrate and test something. Awesome. Oops, that didn't work. It turns out we made some assumptions that was wrong. It turns out that our hardware couldn't actually handle this the way we thought. It turns out we misinterpreted those requirements. Those requirements was actually wrong, and so on and so forth. We find out very late in the project that we have been working on things that could never have worked together, at least, to start with. And with an approaching and looming deadline, well, we freak out. And we try to work very hard, overtime, stressed out, and we also update our requirements because we realize that what we started with was wrong. So that means in a waterfall-heavy process with isolated teams, and in a changing environment where our requirements then, in this case, changes, then the persons on the right side of this V, in this V model, are actually testing things that are already obsolete, because the persons and the teams on the left side have already changed the requirements and developing something new. And with that very stressful environment, you more or less collapse at the end of the project. So, what can we look at then to try to remedy or solve this situation? Well, let's look at how the software projects are running using Agile way of working. And what we can see and why it has been so widely adopted and so successful is that we have faster learning loops. We are having these sprints and so forth, where we have a very heavy focus on what should we do first, what is getting us a value, and by then having these loops, we can then use the learnings when moving forward. This then also means that if we have more frequent deliveries, we can get a faster return of investment, meaning then also lower risks, because for one, we learn things, but we also get money back faster on the investment that we have made, and we can keep our stress level then in a good level. And then we have then this traditional we model that is then, on the other hand, is a very good model actually for system project because it's such a complex development. So we need to keep track of all the different things and have a certain level of certainty when it comes to, for example, not missing critical things in our projects. But with a very long loop, then we have a situation where we get a very late return on investment, we get a higher risk because we can't really reduce any risk until we actually build something and deliver that. And of course, with the looming deadline, stress level goes up. So Tianbao, talk us through this.
Yeah. So Jan has mentioned certain pain points in the system projects, running in the V-cycle specifically. That is due to some nature, like the system projects typically requires very high certainty in the beginning of the projects. They wanted to finish this by the end. Unlike the software projects, they can start already with some kind of feeling. And when we apply Agile, we are working with software projects. They are highly adaptive to the changes. While, as said, for system, we wanted to achieve certain things. So we are not very flexible to the changes in the meanwhile. And in case we realize some risks, typically it happens on the right side of the, right side, on your side, right side of the V when it's integrating. But as Ian mentioned, it's a very long loop. It happens pretty late. That's why this is pretty bad for the system projects. And one of the reasons is the cross-disciplinary collaboration is kind of blocked by silos, as mentioned in different talks. In this way, we were trying to bring our micro-recycle framework to handle those certain pain points. It consists of 3 parts. One is operational methodology, which is Agile way of working. You can choose one or a combination of different ones. We leave this freedom to you. And the other 2 are technical methodologies. One is test-driven development. Another one is minimal viable products. Why we choose these 2? Because, as said, we wanted to make certain for the system projects. We wanted to achieve this. Therefore, we need to maintain the focus. So TDD is trying to achieve this point. While minimal viable products has this advantage, many of the advantages. One of this is we have a foundation to validate very early. So we have a minimal viable products. We can integrate software on the hardware, not completely developed, but already we can validate some functionality. And based on this, we can do increments. Little by little, we build up this product in the system projects. And another advantage is when we have this MVP, we can already deliver to the customer to test some of the functionality they're interested in. And meanwhile, we can get feedback. So it's kind of very short and thin loops that will take advantage of Agile way of working. So the top 2 ones are kind of defining what's the right thing to do. It's not like what's the right product to develop, but in the project execution, what are the right things to do? And then later in this Agile way of working is how to do this in the iterative and small steps. So how does it look like in reality? Remember before it was a very thick way, and now we slice them into thinner ones. Imagine if we start from the yellow one, from the outmost, and when we finish that, or partly finished, then we can switch to the orange one in the middle, and next to the orange, the green one. So the advantage is that we streamline the different work batches in a big project. And imagine the software team and the hardware team, they don't have to finish all the software package and then integrate until the hardware is finished. So we do the part of hardware in priority so that the software part can integrate here, test the function of this, and then the next one, integrate. And in reality, it will look like, okay, for the red one, we already go to the end of this micro cycle, and then we can already start the orange one that goes in the middle phase, and the third one, of green one, it's in the early phase. I will bring you one real example. So this is a CCU, Central Computing Unit. imagine this is the supercomputer in the autonomous car system. So what it does to connect all the sensors on the car, camera, radar, LiDAR, what kind of sensors, and they compute here and output the driving trajectory and control command and so on. So this is background. As it is one electronic system, this PMIC means power management integrated circuit. It manages power, so different components needs different voltages, different currencies, different power up time, and so on. And the peripherals stands, it's a category. It includes connection to the sensors and the internal memory and other supporting electronic components. And then these two core of the system is the MCU, microcontroller unit, and SoC, system on the chip. The difference of them are one is very robust and with higher safety grades. And another one is very, very good at computing. So it has stronger computing power, but not so reliable compared to MCU. That's why in this system we bring these two together to take the advantage of them. And you can also see that it's built up layer by layers. On the very basic one, we have this, and then we have softwares, and in the software we have different software components and so on. So how we apply micro-recycle framework with such project? As said, keep this in mind. We have TDD, so we always try to develop the thing that is defined in the beginning. Meanwhile, we are still open to the changes. And we try to develop MVP so that we can validate ourselves and also deliver it to customer to get some feedbacks. Look, the colored one means the part we've just developed. In the very beginning, it's just the power management part. It's not functional, but it means when we plug in, it doesn't smoke. It's already a very good step. Then we deliver it to the customer. Yeah, it's good. But very soon we will realize something is going wrong, but we can fix it. Because we already go through the micro-recycles, we identify those problems, and we fix it as early as possible. And you can see here, this MCU is already running these read applications with PMIC and peripherals, means the customer can already plug in this kind of prototype or MVP in their car to with a reader to test this function already. Not bad. It's not surprising there are more things going wrong, but we fix it. And you can see the progress of our MVP is growing little by little. This is very encouraging. And the team is seeing the growing, and we are solving the problems. And later you will see a summary chart Yan will show you how it's influenced our team spirit with this. Customer is constantly happy because we are making progress. And as we are approaching to the end of the project, the team is happy, customer is happy, and in the end, we have done that. But in the whole process, you can see that it's not like nothing went wrong. It went wrong, but we fixed them very early. This is the power of micro-recycle framework. And this is a newly added column compared to the previous one. So this system is actually taking the topology of recycle, that is handling the very high certainty for the system projects. Meanwhile, we take the advantage of agile way of working that is on the software. So we are still flexible to the changes. Imagine in the previous example, some components is running short, like currently on the news, one chip is discontinued by whatever reason. And then immediately you can say, can we replace another one? We can validate that. If yes, that's good. And we can expose the risks early. It's also shown. And the synchronization will be encouraged because we see a common stuff we are building up together. I'm a software team, but I'm building up the system together with the hardware team, and so on. So yeah.
Great, thank you for that. So, why is the V cycle or the V model widely used in system project or in automotive project? It is because it gives us a certain level of certainty. It makes sure that we don't miss critical tasks that we need to do. It which also is connected to making sure that we are compliant and we can, for example, install then this component in a car and the car can still be sold in all the markets. So pretty important stuff, which is why this is so popular to use this model, because then we don't miss that. And the right side then validates the left branch then. So it gives us a loop and a certain verification and validation, however, very late. And Agile way of working then is widely used in software project because it is more value-driven approach. It is really good at identifying what we should do next, use the learnings from that thing we did last, and use it moving forward. And the key mechanism here then is that making sure that we close this loop as soon as possible, so we can take that learning moving forward. And this micro V-cycle framework then that me and Tianbao has created then fuses the certainty from the V-cycle and the agility from the Agile way of working. So we take a look again at this graph that we showed before. We have the same one for software, the same one for system, but then we fuse them and say that if we then use the micro V-cycle framework instead, then we can get the benefit of early feedback loops. We can use that in order to make more informed decision moving forward, identify errors, as Tianbao mentioned previously, and hopefully we can also make some kind of deliveries where we can get a return on investment a bit earlier, reducing then once again also the risk because we are having several deliveries, and then the stress level of course in the project goes down, as Tianbao also mentioned.
Yeah, meanwhile, we realized there are 3 secrets how we can apply this micro V-cycle successfully. The first one is to understand the business model. So even though we're developing a system, the understanding of a good business model is very helpful to prioritize what we will deliver to the customer. That matters a lot, even if we are working on the engineering field. And second one is the domain knowledge. So when we try to develop MVP, we do not try to validate the second floor before the first floor is built up. And then the good Agile knowledge help us to adapt and even tailor the Agile way of working in the specific organization for a specific project. I mean, that will improve the efficiency. And if you're interested in this framework, please feel free to contact us. This is the LinkedIn profiles of Yan and me. And we also have a paper draft for reference if you're interested. Thank you.